object at rest stays at rest, and an object in motion stays in motion at the same speed in the same direction, unless acted upon by an unbalanced force. Let's consider this marking pin for a moment. There's two forces acting upon the marking pin. There's the force of gravity down, and then there's the force of the sewing ring pushing up on the marking pin. Those two forces are balanced. They act in equal and opposite directions such that the marking pin stays at rest. Now we can disrupt this equilibrium of forces between the down and the up if we pull the sewing ring out from underneath the marking pin. And if we do, there will be only one force acting upon the marking pin, and that's a down force, the force of gravity. And with that force being the only force, it will no longer stay at rest, but instead accelerate in the direction of the unbalanced force. To do this, what I have to do is abruptly move the sewing ring out from underneath the marking pin, and we should observe that marker falling straight down. So if you believe in physics, let's give it a try. You gotta believe.
All right, so that was an awesome video. I thought I would just show you that before we proceeded into more examples of Newton's first law. All right, so welcome back, guys. This is my second video on Newton's first law. And Newton's first law says the object in motion stays in motion, object at rest stays at rest unless acted upon by unbalanced force. All right, and so when you get into forces, the key skill you're going to learn is how to draw free body diagrams. And what a free body diagram is just a picture of an object with its forces on it based on a certain scenario. So our scenario here, we have this yellow glass-shaped bottle, and from the video, it was a ring on top of it. And right on top of the ring, he had a expo marker just standing at rest on top of it. And so what Newton's first law says, it says an object in motion stays in motion, an object at rest stays at rest. And so really we have two scenarios. So we have the first scenario, and then we have the second scenario. So the first scenario is going to be where we have the marker, and I'm going to draw a box just to represent the marker. It's not a box on top of here. This is a marker, but just for simplistic purposes, I just want to just state the marker as a box, so I don't have to be too confusing. Hopefully this is not confusing. All right, so the first case is when the object is at rest. So when the marker was at rest, it's just standing still. So that means that it's balanced out. It's in equilibrium. That means that it is balanced out with a force pointing here and a force pointing up. Now, equilibrium means that these two forces are exactly the same magnitude, but they're just pointing in opposite directions. And if they're the same magnitude and pointing in opposite directions, that means that they're in equilibrium, they cancel out, and therefore the object's at rest. And we're going to talk about what these forces are in the next video on Newton's second law. All right, and so that is when the object is at rest. So the free body diagram when the object is in motion is going to be where this ring here is canceled out, is gone. He just swipes it off. Now, Newton's first law says an object in motion stays in motion, an object at rest stays at rest. Now, this is the case where the object's in motion. Now, let's pretend and say that this ring was not here, like we said before. This marker will have some type of velocity, some type of speed. And once this ring just goes away, it's going to maintain that speed as it did previously before it was even there. All right, so that free body diagram is going to look something like this. It's just gravity pulling the marker down. And this is when the object is in motion. The object is in motion. And so now the block is not in equilibrium. The forces do not balance out or cancel out. So therefore the object will be moving. All right, and that's Newton's first law. Object in motion stays in motion. Object at rest stays at rest unless acted upon by unbalanced force. So if it's balanced, that means it's not moving. If it's unbalanced, that means it's moving. Not moving and unbalanced It's moving. All right. Thank you.